So here in this video, I just want to describe what is discrete mathematics. Right? So discrete mathematics. Okay, so discrete means, just the definition means separate, distinct, just countable objects. Now, what we mean by countable, right? Not necessarily finite, but countable, right? So when we think of like in algebra, right, we're used to having functions that are defined across the real numbers. Right? And the real numbers, they are not countable, right? We can't put them in any kind of order, right? Because if we think of any real number, like a half, pi, right, root 2, 4, right, there's no next number after those, right? That doesn't exist, right? So when we think of discrete, we think of countable values, right? So as we're here, this is defined across, right, negative infinity to infinity. When we think of discrete, right, we think of, right, if we look at this, we just look at like the countable values, 2, 4, right? We think of just those specific points, countable objects, that we can put them to some order, right? We can count them, right, putting them in order, 1, 2, 3, 4, etc., right? So if we think of this, right, 1 plus 2 plus 3, all the way to n, right? And again, this is not necessarily finite, right? We could see here something like this. Right? Countable, but infinite, right? We can put them in this type of order, right? So when we say discrete and we're talking about countable, this is the idea that we are talking about here, right? Where we can put them in some kind of order, where we can count them using our integers. All right, so that is what discrete mathematics is, right? So we're not going to be working with intervals, right? We'll be working with these countable numbers, right? So here, this course will focus on reasoning and structure, not so much computation, right? So we're going to focus on kind of why things work, trying to reason through a problem, right? That will involve writing proofs, right? Giving explanations, right? Having graphs, right? And then our structures we'll be talking about, functions, right? But not functions as we are used to interpreting them across the real numbers, but across, right, discrete values here. Okay, so not so much computation, but reasoning and structure, right? We'll get back to those kind of main core topics in this course, right? Reasoning and structure. Right, and we get more what those structures are, right? They can come across as sets, functions, sequences, relations, and graphs, at some types of graphs. Okay, all right. And some common problems here that we have seen is common discrete math problems are this handshake problem. To get an idea. Right, of a classic discrete math problem. So the handshake problem is, let's say, there are 6 people at a party, right? And the idea is that everyone shakes hands exactly once. All right. Okay, so now again, right, we put order to kind of our thoughts. We kind of reason through this. One way to do is like, right, we think of kind of an abstract way. If we have we think of these kind of nodes here as the people at a party, right, to kind of start just organizing excuse me, our thoughts here. We could say all right, we have one person here, right, and he shakes the hand of the other 5 people at the party. Okay, So that is a total of 5 handshakes, right? Now, once he shakes the hand of another person, right, that person no longer needs to shake the hand of that person back, right? That event has been completed, right? So here we start here. So now we focus here. This person has completed his obligation. He has shaken hands with everybody in that party, right? Now, if we go here, let's say, all right, well, what about this person here? Well, he's taken care of that one, so he only needs to shake hands with these other people here. So that is 4. All right, so that's 4 more handshakes. All right, and we can continue kind of working through this here. Or now if I focus on this person here, he's already shaken hands with this person here. And also this person here, right? We've taken account for it already. So he only needs to shake the hands of these other 3 remaining people. So that's 3 handshakes. And then that same logic, right? Focusing on this next person, he needs to shake hands of these other 2. All right. And then this last person, well, there's 2 more. They just shake hands with each other. All right. Okay, and then here, an example of a type of structure, right? Here, now the next case, how we could build from this is, well, how would it take, what if there was an n number of partygoers, right? 50, 100, right? What kind of structure can I use? What equation can I use, right? A function that takes in, again, discrete values, right? Whole numbers, integers to calculate the number of handshakes. So that's kind of the idea of this discrete mathematics, right? That we kind of reason through the problems. The computation is minimal, right? And it's not the main goal here. It's really just to have a sense of abstraction here to the problem that we can generalize to n number of people using these models here as a foundation.